All right, today we're going to be looking at section 8.1, the distribution of the sample mean. The two objectives that we're going to be looking at are we're going to try to describe the distribution of the sample mean when it comes from a normal population, and we're going to try to describe the sample mean when it comes from a non-normal population. Okay, so you got some good reading, some detail that talks about the distribution. Usually we're going to have a population, and we're going to look at taking samples of size n, so multiple samples. So like if we have like the whole United States, we might take multiple samples of 100, and so we'll do that all over the state until we take every single possible sample, and all of those different samples will come together to make a sampling distribution. The mean of that sample would be like if I took all of those different samples of size 100 for this example and I averaged them, the mean would be equal to the population mean. So that's what this is saying. The standard deviation will be a little bit different, and so we'll kind of talk about that as we get there. But that's the idea behind this. We're going to be taking samples from a larger population and looking at its distribution. So this is saying samples of size 9. Here are some different examples. You'll get different means, but when you take the mean of all of those means, it will be equal close to the actual population mean, which is in the center. When you do the standard deviation, you'll notice there's a little less spread in the sample than there is in the whole population, and the way we account for that is the standard deviation of the sample is going to be equal to the population standard deviation divided by the square root of n. So the sample mean is equal to the population mean. The standard deviation of the sample is going to be equal to the population standard deviation divided by the square root of n. So that will be the difference. That's the sampling distribution. If it comes from normal, we'll just use the normal mean and the normal standard deviation. So here's an example talking about approximately normally distributed. And then we get into when it's not normal. So when it's not normal, there's different things. We can look at the shape. So you might have a skew to the right distribution. You may have skew to the left. You can have uniform, binomial, some other distributions that we've talked about and seen, or maybe have not seen. Based on those distributions, we will start to apply the central limit theorem. This is very important. Make sure you pick up on that. So the central limit theorem says, regardless of the shape of whatever population we're dealing with, the distribution of the sample becomes normal as n increases. So the bigger the sample, the closer we are to the normal distribution. How big does it need to be? Well, we start talking about that coming up. So these are just some different shapes. If n is 25, okay, this is 10, this is up to 25. The bigger we get, this is when it was 4. Not quite normal, but the closer we get, the bigger n gets, the closer it is to this normal shape. So some distributions get normal when they're small. However, just to be on the safe side, the general rule of thumb says when it's greater than or equal to 30. So that's going to be the central limit theorem. Whenever we have some unknown population or distribution, we will apply the sample mean being approximately normal when we have a sample size greater than or equal to 30. That's going to be the general rule of thumb. If you look at the reading, some of them approach normal when it's smaller based on the shape. However, general rule of thumb on the safe side, we're going to say 30. That's the central limit theorem according to our text. So if we know it comes from a normal, again, we can use the normal distribution. If not, we will use the standard normal, or the approximate normal distribution. So the difference is z equals x minus mu over sigma. Standard normal is going to be the sample mean minus the mean over sigma, and sigma, remember, is the standard deviation over the square root of n. It's still the normal z-score, but it's a little bit different, as you can kind of see. And then that's pretty much what we're looking at here. So we'll jump into my math lab and actually practice some problems using this information.